Welcome to a lesson on how to graph a translation of the basic or parent rational function f of x equals 1 divided by x. So this video does assume we're familiar with the basic rational function f of x equals 1 divided by x, which is graphed here. And we're first asked to graph g of x, which equals 1 divided by the quantity x plus 3, as well as g of x equals 1 divided by x minus 2. Let's begin by looking at an animation showing translations of f of x equals 1 divided by x. So here we have the graph of the parent function f of x equals 1 divided by x, and we're going to look at how the value of c and d affect the graph of the parent function. Notice how c is the value added to x in the denominator, and d is the constant added on the end. Let's see what happens when we change the value of c. Notice when c is positive, the graph is shifted to the left, which means we'd have x plus a constant in the denominator. So if c is positive, the graph is shifted left. Notice when c equals 4, the graph is shifted exactly 4 units to the left. And this should make sense because if we wanted the y values of the parent function and the translated function to be the same, because we have the quantity x plus 4 in the denominator of the translated function, we'd have to use inputs or x values that are 4 or less to get the same outputs or y values. And notice how when c is negative, or we have x minus a constant in the denominator, the graph is actually shifted to the right. So notice here, when c is equal to negative 3, we'd have the quantity x minus 3 in the denominator, and the graph is shifted exactly 1, 2, 3 units to the right. And again, this should make sense because if we want these two functions to have the same y values or function values, the inputs or x values of the translated function would have to be 3 units larger to get the same outputs or y values, because the function would be 1 divided by the quantity x minus 3. So again, if c is negative, the graph is shifted right. If c is positive, the graph is shifted left. Now let's set c back to 0 and determine how d affects the graph of the parent function. Notice how if d is positive, the graph is shifted up d units. And if d is negative, the graph is shifted down d units. So if we have minus a constant on the end, the graph is shifted down. If we have plus a constant, the graph is shifted up d units. So going back to our lesson, to summarize, we can say if our function g of x is equal to f of the quantity x minus c, then the graph is shifted right c units. If g of x is equal to f of the quantity x plus c, the graph is shifted left c units. And if g of x equals f of x minus d, the graph is shifted down d units. And if g of x equals f of x plus d, the graph is shifted up d units. So notice how here we can say that g of x is equal to, if we replace x with x plus 3, the functions would be the same. So we can say g of x equals f of the quantity x plus 3. So because we're adding 3 to the input x, this is going to shift the graph of f of x left 3 units. So we'll say g of x is f of x shifted left 3 units. So now to graph g of x, we'll use these key points on the parent function and shift them left 3 units. And we'll also shift the vertical asymptote left 3 units. Let's first shift the points. So let's shift the point 1, 1 left 3 units, which would be here. This point left 3 units, which would be here. And this point left 3 units, which would be here. And now I'll shift these 3 points left 3 units. So 1, 2, 3, 1, 2, 3, and 1, 2, 3. For the parent function, the vertical asymptote is the y-axis, which is x equals 0. If we shift that left 3 units, the vertical asymptote will be x equals negative 3, which is here. If we shift the horizontal asymptote 3 units left, it'll be the same horizontal line, which is the x-axis. This is all we need. in order to make a nice graph of g of x. It'll pass through these 3 points and approach the vertical and horizontal asymptotes. And it'll also pass through these 3 points and approach the horizontal and vertical asymptotes. So this is a graph of g of x, which equals 1 divided by the quantity x plus 3. Notice how knowing the translation of the parent function saves a lot of time rather than making a table of values. Now let's look at g of x equals 1 divided by x minus 2. Because f of x equals 1 divided by x, we can say that g of x is equal to f of x minus 2, which means g of x is f of x shifted down 2 units. And this should make sense because if we take the function values or y values of f of x and subtract 2, it will shift each point down 2 units. So let's take these 6 points and shift them down 2 units. So the point 1/2 comma 2 down 2 units would be here. This point down 2 units would be here. This point down 2 units would be here. And now for these 3 points, down 2 units, down 2 units, and down 2 units. Now here, because we have a vertical shift, we will now shift the horizontal asymptote down 2 units. So right now the horizontal asymptote is the x-axis, which is y equals 0. The new horizontal asymptote will be y equals -2, which should be this horizontal line here. And of course, if we shift the vertical axis down 2 units, it won't change. It'll still be the y-axis. So now we can easily graph g of x equals 1 divided by x minus 2. It'll pass through these 3 points approaching the asymptotes, as well as these 3 points and approach the asymptotes. Let's take a look at 2 more examples. Here we have g of x equals 1 divided by x plus 1, which means we can say that g of x is equal to f of x plus 1. So because of the plus 1, we know that g of x is f of x shifted up 1 unit. So we'll shift each point of the parent function up 1 unit, as well as shift the horizontal asymptote up 1 unit. Let's first shift the points, so up 1 unit, here, here, and here, as well as here, here, and here. And we'll shift the horizontal asymptote from the x-axis, or y equals 0, to y equals 1. Shifting the vertical asymptote up 1 unit does not change its location. It is still the y-axis. So the graph of g of x equals 1 divided by x plus 1 would have one piece here and one piece here. And for our last example, we want to graph g of x equals 1 divided by the quantity x minus 2. Notice here we can say that g of x is equal to f of the quantity x minus 2. And because we have the quantity x minus 2 here, g of x is the graph of f of x shifted right 2 units. So we'll take the 6 key points on the parent function and shift each of them right 2 units. So this point right 2 units, this point right 2 units, and this point right 2 units. This point right 2 units, this point right 2 units, and this point right 2 units. And we'll also shift the vertical asymptote right 2 units. So instead of x equals 0, we'd have x equals 2, which is here. And if we shift the horizontal asymptote right 2 units, it doesn't change. It's still the x-axis. And now we can easily graph g of x equals 1 divided by the quantity x minus 2. It'll pass through these 3 points and approach the asymptotes, and pass through these 3 points and approach the asymptotes. So by knowing the translations of parent functions, we should be able to more easily graph more complicated functions. I hope you found this helpful.